Okie dokie, good day, everyone. We are going to start off today with lesson 211. It is actually the last lesson in unit 2. Tomorrow we will start a little bit of review. We'll have a mini quiz on probably Thursday or Friday. I may give it as a take-home assignment. And then next Wednesday, right, next Wednesday being the 30th, of September, right, 9:30, so I'm going to do the 9:30, we have our Unit 2 exam, okay, so Unit 2 exam, sorry for bad handwriting there, just as a reminder, so let's make sure that we are really keeping on top of our work from here on out, and make sure that we get caught up on anything we're missing. Alright, so the first thing here we're going to do now, find the equation of the line passing through -4, 5, that is perpendicular to y equals 2x plus 1. Okay, so this perpendicular, and that's what we're going to use. Yesterday we used our y minus y1, also known as point slope form, x minus x1. Okay, so we're going to use the same thing. However, there's a very key piece here, is our perpendicular slope. The only reason I care about this equation is because it gives me a slope of 2. Okay, well, that being the case, if it's perpendicular, I'm just going to tell you right now, this slope here is equal to -1/2 because we're using the opposite reciprocal. Okay, so this is the slope I'm going to use when plugging into the point slope form. I'm also going to use this x1, excuse me. So this x1 and this y1 to put in this spot and in this spot respectively as well. Okay, so let's go ahead and do that now. So y minus y1 equals 5 equals, our slope of -1/2 times x minus x1. Well, look, in this case, x1 is -4. Okay, so remember this here is like saying x plus, 4. Okay, so this is like saying x plus 4. Okay, and I would distribute this here and here. So, and at the same time, I'm actually going to go ahead take this plus 5 and put it over here on this side so I can go ahead and get y all by itself. So let's clean this up a little bit. So when I distribute that -1/2, I would get -1/2 x. Negative times a positive is negative, so negative minus 2 plus 5. Then one more time to clean it up, simplify, -2 plus 5 is the same as saying plus 3. Okay, so this would be our final equation for the line that goes through -4, 5 and is perpendicular to this equation. Okay, remember they create a 90-degree angle when they intersect, perpendicular. All right, let's move on with today's lesson. So yesterday we talked about the distance between a point and a line. Today we're going to talk about the distance between parallel lines. Okay? Okay, I'm going to try to write pretty small here, but by definition, parallel lines do not intersect. An alternate definition says that two lines in a plane are parallel if they are everywhere equidistant, right? Equally distant, right? So that means that the distance between two lines measured along a perpendicular line to the lines is always the same. So basically they're saying these perpendicular lines here should all be equal length in order for this line and this line to be parallel. And that makes sense. Think of a ladder, and that's kind of what they give us here. So down here on this other part, and I'll just write it in, the distance between two perpendicular lines is the perpendicular distance between one of the lines and any point on the other line. Okay, so let's go ahead and get right into the guided practice day. We'll start off with the my turn. Just follow along for us in your pair deck. Find the distance between parallel lines L and M with the equations y equals 2x plus 1 and y equals 2x minus 3, respectively. What that means is that use it in the order that they've given you. So they're basically saying that this one here will be my L. Okay, so this will be the L, and this one over here will be the M lines. Okay, so that's what they're saying respectively in order. So let's go ahead and take one of these lines at a time. So let's take line L, okay, and I'm going to go ahead and do these in blue. Okay, so let's take line L. And when I plot that one there, I'm going to go to the y-intercept of plus 1, and I start right there. And I'm going to go up 2 and over 1 to make it a positive slope of 2 over 1. Okay, I can also drop -2 over a -1, still positive, okay? So I can go here, and then keep going, and I would have something that looks like this. And I'll plot the other one in green here, which is line M. That was L, now line M is coming up. And there are our two lines. Okay, so they are parallel. I know not the greatest drawings, but bear with me. So we've done step 1, graph both lines L and M. Step 2 says sketch line P through the y-intercepts of line M. So the y-intercept of line M, of course, is -3, and I could draw something like this here. So here, this would be line P. We're told this, we're on step 2, line P, through the y-intercept of line M. Step 3 says, find the equation of line P. Since P is perpendicular to the lines, we'll take the opposite reciprocal of line M. So I know both of these lines here have slopes of 2, which means the slope, or the, right, this here means perpendicular slope. Here will then be, instead of 2, will be -1/2, because we are doing the opposite reciprocal, okay? Don't forget that word. Sorry, it's really bad. So step 3, we're told again, find the line of the equation of P. We know we know the slope, and we also, in fact, know a point. So we can use point slope form here. So we say y minus y1 equals m times x minus x1. Okay, so substituting the values for P, I know that this point right here is -3, 0. Okay, so that's the point I'm going to use. I'm just going to put it over here so I don't forget it. So I'll say y minus y1 equals, so you can see how I've put in the parts that I've been given into the point slope form, and I was able to get this equation that I'm going to circle in green here as the equation for line P. Remember, this is line P's equation. Okay, step 4, use a system of equations to determine the point of intersection for line L and P. And I'm sorry, I'm realizing I confused this here. It should have actually been 0, -3. So let me start that part again. Okay, my apologies there. I went ahead and corrected all the work there. I basically just had to switch out the x and y, and I was left with this equation right here. Y equals -1/2 x minus 3. Again, this is for line P, just to make sure we remember where we're at in this problem. Step 4 says, use a system of equations to determine the point of intersection for line L and P. So I'm going to take line L, I'm going to take line P, and I'm going to set them equal to each other. Okay, so let's take line L. Remember, line L is this guy up here. So I'm basically going to set that right here, and I'm going to say, well, y equals 2x plus 1. Okay, and the other one, well, line P, well, here it is right here, right? It's when it's y equals, so I'll just... So on step 4, we're going to use a system of equations. This is something you learned last year, where basically you're setting two equations equal to each other, okay? Those equations being, of course, y equals 2x plus 1, or line L, and y equals -1/2 x minus 3, or line P. So let's make them equal to each other. Okay, so now I'm solving. I've set them equal to each other, and I'm solving. And I have solved for x now. And now, in order to get the y value, what I'm going to do is substitute x equals -1.6 into line L's value. Okay, so I'm going to go into another screen on that, and you can go back in a second. Okay, so I'm right here. I've just minimized this. I basically took a screenshot and just kind of shrunk it. So again, I'm going to use line L, which is y equals 2x plus 1. Again, I'm going to substitute the value of x equals -1.6. So this equals y equals 2 times -1.6 plus 1. Do the math. So now I have my new value of this x and this y. So let's go ahead and do a ordered pair of negative 1.6 comma negative 2.2. And what does this mean? What does this pair even do for us? Well, basically what this is telling us is that the point of intersection, this being right here, is right there, right? So we have basically negative 1.6 comma 2.2. That's that point. So we have algebraically solved for it. And we're going to go ahead and step 5. In case you can't see it, it says use the distance formula to find the distance between the endpoint of segment P. So we'll take step 5 here. Again, we'll be using a distance formula here, and just we've been using this quite a bit. So x2 minus x1 squared plus y2 minus y1 squared. So when I substitute in the values, I will be using this negative 1.6 comma 1.22, and let's go ahead and put it here in red just so we have it in a different color there. We'll be using 0 comma negative 3 because that is, again, this right here. That's the distance we're trying to find, right? The distance between two parallel lines. So substituting our values in, we get, okay, substituting those values and simplifying a little bit more, I get 1.6 squared plus negative 0.8 squared. Okay, last step, I would get 2.56 plus 0.64, take the square root of that, and I should get the square root of 3.2, or around, let's say, 1.79. And this, ladies and gentlemen, is so important because this is the distance between two parallel lines right there. Okay, and I'll actually kind of highlight it there in gold orange so you can take a look at that. All right, that was a lot. Let's go ahead and do another one. I know it says your turn, but we're going to do it together. Okay, this is basically the exact same type of problem. We're going to find the distance between parallel lines R and S with the equations, with these equations respectively, right? So this would be R and this would be S. Okay. Step 1, graph both lines R and S. Let's do that now. Okay, so I have, I know it's a little messy, but I did R and S there, okay? So I've done step 1. Step 2 says sketch line P through the y-intercept of line R. So I'm going to take line P here in green. They tell me the y-intercept of R is right here. Okay, so my line should look something like this. Okay, and this is, of course, line P. Okay, I'm going to do it here. This is line P. Alrighty, so we've done that. Step 3, find the equation of line P. Since P is perpendicular to the lines, take the opposite reciprocal of slope of line R, use the y-intercept of line R as one of the endpoints of the perpendicular segment. Okay, so your work should look something like this. Remember, we're taking 0, 5, and the perpendicular slope is equal to 1 over 3 because the opposite reciprocal of negative 3 is a positive 1 over 3. Okay, so I'm going to fill it in, substitute into the point slope form here, and we should get something like this. Alrighty, so substituting the values in, I get y equals 1/3 x minus 5. And remember, this is line P, that's why I did in green here. So we have now 3 lines. Okay, step 4. Use a system of equations to determine the point of intersection for line S and P. So, knowing that I have line P here in green, knowing that I have line S over here is this line right here. I'm just going to put S right here again. I'm going to do it in red just so it's kind of, you see where I'm writing it here. I'm going to use those 2 lines, and I'm going to set them equal to each other. Well, I know that, so I'm basically going to say P equals S. So this is what it looks like. So I'll say 1/3 x minus 5 being the equation for P equal to line S, which is negative 3x plus 6. So now I can add 3 to both sides here. 3x. Okay, and I would add 5 at the same time to both sides to go ahead and isolate the variables there. I'm left with 3.3x equals 11. Simply divide both sides by 3.3, and x equals, now I've got x equals 3.3. Again, we are looking at the point of intersection for lines P and S, so it's right around there. Now again, I have an x value. In order to solve for that y value, I'm going to get this x equals 3.3, and I'm going to substitute it into line S's equation of y equals negative 3x plus 6. But instead of the x, I'm going to fill in 3.3. And when I solve for y, I would get x equals negative 3.9. So now I have established that this point right there of intersection is 3.3 comma negative 3.9. Okay? And last, we're going to use the distance formula to determine the distance in this orange. So we're going to use the distance formula here to find the distance between the two parallel lines, which would be this segment right there. And I'm going to go ahead and do that here. Okay, so distance formula here is distance equals, and that's going to be x. Okay, so I've substituted in values, and I'm now just simplifying. Okay, I would finally get here d, the distance between the 2 points, or the distance between, excuse me, the 2 lines, would be the square root of 12.1, or around 3.48 units. Okay, I know that's a lot of work, ladies and gentlemen, but this is ACT type of work. Okay, we have to be able to go through this. Again, nobody expects you to be an expert now, but over the course of time and practicing over and over, you will become that. Alrighty, so let's go on. Okay, I have also shortened the assignment to where you are not going to be responsible for all of the independent practice. I only want you to do numbers 3, numbers 4, and number 5. And, of course, the exit ticket. If you need to take a little more room and send me a screenshot of your work on paper, that is totally fine as well. Okay, and I just want to make a note here. So this will be graded. Okay, do this in Pear Deck, of course. That's what you're working in anywhere, but just to make sure that everybody's going to go ahead and do it, so I can put that into your grade book for you. If you have any questions, please feel free to reach out. Thanks, guys.